In this podcast, we're going to be graphing polynomial functions. Specifically, actually, though, we're going to be writing the equations of polynomial functions from a graph. All right, so our steps to write the equation, it's kind of like the steps to write the equation of a polynomial function when it's in a quadratic function when it's in intercept form. Because basically, that's what we're going to be doing. We're going to be writing our polynomial function in intercept form, in factored form, and then solving for a, and then we're just going to leave either we'll leave our function in factored form, or maybe we'll put it in standard form. And I'll show you what that looks like. So my very first step is to identify my x-intercepts. The x-intercepts is where our graph crosses the x-axis. So we have 1 at -3, 0. We have 1 at 1, 0, and we have 1 at 4, 0. Okay, so now we need to take those x-intercepts and change them to factors. Remember that the factors are always going to have the opposite sign of the x-intercept, and that's because we set our factors equal to 0 and solve for x. So it means to solve, we have to add the opposite. So if x plus 3 is the factor, and we set that equal to 0, we'd have to subtract 3 from both sides to solve for x, which means x would be -3. So -3, 0 is the x-intercept, x plus 3 is the factor. If 1, 0 is the x-intercept, x minus 1 is the factor. And if 4, 0 is the intercept, x minus 4 is the factor. Right? So now, before we go any further, we want to make sure that we check for multiplicity. Now, multiplicity is a factor that appears more than once. Specifically, we're looking for multiplicity of 2. Right, so for multiplicity 2, the graph will touch the x-axis and turn back. Touch and turn. Okay. All right, so if we look here, and if we have an odd multiplicity, we cross. So you can see here we cross at -3, we cross at 1, we cross at 4. We actually cross it. We don't just touch and go back the other way. So these are all multiplicity 1. Right? So that just means that each factor will only occur once. Right, so we need to find the value of a. So to find the value of a, you substitute a point for x and y and solve for a. Right, so we have, I'm just going to set this equal to y, because my y value depends on my function here. Y equals a. Let me make that a little bit nicer. A times x plus 3, x minus 1, x minus 4. All right, so a is my leading coefficient when I'm in factored form. It's very much just like when we were writing the equations of the quadratic functions in intercept form, just that we have more factors. All right, so we need to substitute a point for x and y and then solve for a. We have a point right here that we're given. When x is 0, y is 12. So I'm going to plug in 12 for y, and I'm going to plug in 0 for the x's. And then we'll simplify. So 12 equals a times 3 times -1 times -4. Just added there, subtracted. And then we multiply. So 3 times -1 is -3 times -1 is +12. So 12 equals 12a. If we divide both sides by 12 to solve for a, 1 equals a. Now, a will not always equal 1. In this case, though, it does. You don't need to write the a value if it is 1. Okay, so 1 is understood. So the equation, our equation in factored form, is just going to be f of x, we'll put it in function notation, equals, I can leave off a, and so it's just my factors, x plus 3, x minus 1, x minus 4, and so now we've written the equation that goes with this particular graph in factored form. I'm going to go over some more examples, but I hope that made sense for you. Let's look at another example. All right, so here's our second one. And our first step is to find the x-intercepts for our graph. All right, so we have one here. Oops. I'm going to write in a different color this time. Let's write in blue. New problem, new color. Come on. A little slow when I'm recording. Okay. So we have an x-intercept there, an x-intercept there, an x-intercept there, and an x-intercept there. So you can see we have 4 x-intercepts. We have one at -5, 0. We have one at -2, 0. We have one at 3, 0. And 5, 0. Okay, we'll check for multiplicity. And you can see we don't have any. We cross, 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 cross. We'll change our x-intercepts to factors. So let me just move that up a little bit. If -5, 0 is the x-intercept, x plus 5 is the factor. If -2, 0 is the intercept, x plus 2. If 3, 0 is the intercept, x minus 3 is the factor. And if 5, 0 is the intercept, x minus 5 is the factor. We can also tell here, by the way, we should have 4 intercepts. We can see that we're an even function. Both ends are going the same way. We've got 4 x-intercepts. We've got 3 turning points. 1, 2, 3. All right, our degree will be 1 more than our turning point. So if we have 3 turning points, we'll be degree 4 in general. Now there are some functions with very few turning points. It's because they don't have a lot added to them. Like x cubed only has 1 turning point. It's not a very interesting graph. Doesn't have anything added to it. So it doesn't really have a bunch of peaks and valleys. All right? No, excuse me. X cubed doesn't have any turning points. It's even boringer. So just because your maximum, you have a certain value that's your maximum, doesn't mean you'll always have your maximum, but usually. Just the power functions don't. Like x to the 4th has 1 turning point, not 3. But if we had something like this, right, with more terms in it, now you can see we've got more x-intercepts. All right, so we've got to find the value of a. So we're going to write y equals a times x plus 5 times x plus 2 times x minus 3 times x minus 5. All right, and we have 1 point, 0, -15. So -15 equals a times 0 plus 5, 0 plus 2, 0 minus 3. Oh, I shouldn't have checked for multiplicity right there. And 0 minus 5. Right, so -15 equals a times, we got 5 times 2 times -3 times -5. So -15 equals 5 times 2 is 10. Times -3 is -30, times -5 is positive 150. So we have 150a. Are we expecting a to be positive or negative? Well, if you look at the graph, both ends are down. You should be expecting a to be negative, which it is. We'll divide both sides by 150. And so here, -1/10 equals a. And the equation in factored form will be f of x equals -1/10 times x plus 5 times x plus 2 times x minus 3 times x minus 5. And there we go. We're done with this one. All right, so you're going to follow the same set of steps all the time, so it's not really very, very difficult at all. All right, so we'll do this one. All right, so the x-intercepts, we have one here, here, and here. So at negative 3, 0, and at 1, 0, and 2, 3, 4, 0. We have 1, 2, 3 turning points. Both ends go in the same direction. Should be something to the 4th power. Now let's check for multiplicity. All right, so notice here, we touch and turn. Right there, okay? So that means this is multiplicity 2. All right, so let's change our intercepts to factors. So we have, if negative 3, 0 is the intercept, x plus 3 is the factor. If 1, 0 is the intercept, x minus 1 is the factor. And if 4, 0 is the intercept, x minus 4 is the factor. All right, so now we'll plug in a point for x and y and solve for a. Oh, almost forgot. Got to put in my multiplicity 2. So x plus 3 appears twice. All right, so let's give him a square, because there's 2 factors of x plus 3. All right, so we have y equals a times x plus 3 squared times x minus 1 times x minus 4. And I plug in for x and y, so there's my x. There's your y. Your x-intercept, y-intercepts are really good choice to use. You can't use your x-intercepts because you already have them represented in your factors. Sometimes there's a turning point. That's a good point. All right, so here we have 3 equals a times 0 plus 3 squared times 0 plus minus 1 times 0 minus 4. All right, so that's 3 equals a times 9 times negative 1 times negative 4. All right, so 9 times negative 1 is negative 9 times negative 4 is positive 36. So 3 equals 36a. Divide both sides by 36. And you should reduce this. Okay, both of those are divisible by 3. 3 divided by 3 is 1, and 36 divided by 3 is 12. So 1/12 is what a is. The equation in factored form is f of x equals 1/12 times x plus 3 squared times x minus 1 times x minus 4. So I hope you're not finding this too difficult, because it's the same set of steps. So it's just a little algebra, just a little, identifying some points, rewriting as factors, setting up your equation, plugging in for x and y, and solving for a, and then you've got your equation. This one is in your notes. Okay? It's a little tucked off to the side there. It's on the same page we were taking notes on. It is in your notes, so find that. And let's write the equation of this one. Now this time we're going to put it in standard form. Okay? So notice it says write the equation to match the graph in standard form. All right, which means that we're not going to leave it's not going to be in factored form. We're going to multiply that out. Okay, so first thing we'll do is we'll identify the x-intercepts. I got to watch our graph. It's going up by 2, so you got to be careful. 2, 4, 6, 8. Okay, so this point here is 2, 0. This point here is negative 1, 0. This point here is 4, 0. Excuse me, negative 4, 0. All right, so our x-intercepts, negative 4, 0. Negative 1, 0, and 2, 0. Let's change those to the factors. Oops, come on, move up there a little bit. All right, so that would be x plus 4, x plus 1, x minus 2. Check for multiplicity. All right, so I cross, cross, cross. There's no touch and turn, so it's all multiplicity 1 for all of our x-intercepts. So we're going to solve for a by setting that equal to y and plugging in for a point. So y equals a times x plus 4 times x plus 1 times x minus 2. And so now we need to identify a point. And the y-intercept is a good point. That point there is 0, -8. That one's a clear point. All right, so we have -8 equals a times 0 plus 4 times 0 plus 1 times 0 minus 2. So that's -8 equals a times 4 times 1 times -2. So 4 times 1 is 4 times -2 is -8. -8 equals -8a. We divide both sides by -8, and a is 1. All right, so now we're going to write the equation in factored form. We don't need to include the a. F of x, because it's 1, equals x plus 4, x plus 1 times x minus 2. All right, so now we're going to put it in standard form. To put it in standard form, we're going to have to multiply our factors. All right, so and when you're multiplying factors, you can only multiply one pair at a time. So we're going to have f of x equals x plus 4 times x plus 1. All right, so we'll multiply those. And then we'll multiply all of that times x minus 2. But we're going to work with these two first. Okay, so put this in your notes as well. So f of x equals, right, so I'm going to multiply the x times x plus 4. Actually, let's do it as FOIL. I won't write it out as distribution. The second part I'm going to have to write out as distribution because I'm going to have 3 terms times 2 terms. But this one we'll just do FOIL. X times x gives us x squared. That's the first outer. X times 1 would be positive 1. X. The inner terms, 4 times x would be positive 4x. The outer terms, 4 times 1 is 4. And we're going to simplify that, and we're going to multiply all of that times x minus 2. So to simplify, you're just going to combine your like terms. So you can add the x and the 4x. So that is x squared plus 5x plus 4 times x minus 2. All right, and now we're going to multiply all of the terms in the first one by the 2 terms in the second one. Okay? So that means we're going to have f of x equals, and I'm going to change the order. Now, I multiplied it this way. Some students find it easier to multiply the last 2, and then just because it's easier to see the distribution. Okay? So actually, I'm going to take this back, and I'm going to multiply the second 2. Now, I could flip the order. It doesn't matter the order you multiply in, but I'm just going to multiply these 2 first. Some students just find it easier if I multiply the last one so that automatically that first pair is right in front, and I forgot to do that. So x plus 4 equals, so I'm going to multiply the last 2. X times x gives me x squared. Outer terms, x times -2 would be -2x. Inner terms, 1 times x is x. And last terms, 1 times -2 is -2. Combine our like terms, f of x equals x plus 4 times x squared. That -2x plus x is a -x minus 2. Now, our product, our expressions now look a little different. That's just because I multiplied the last 2 together instead of the first 2. But if we multiplied the first 2, we could just flip it so that the one with the 3 terms is second and the one with the 2 terms is first. It just looks a little visually more pleasing to write it like this than have to distribute 3 terms to 2 terms. Just seems nicer to distribute the 2 terms to the 3 rather than the 3 to the 2. And you'll see what I mean in a second here. So we're going to multiply the x times x squared minus x minus 2. And we're going to multiply the 4. Oh, I could really use a little bit more space. Times, I may have to squeeze it, x squared minus x minus 2. Okay, so now we're going to have 6 terms. And maybe some of them are alike, so we can add those together. X times x squared gives us x cubed. X times negative x gives us negative x squared. X times negative 2 is a negative 2x. Okay, so we distributed the x to those 2 terms. Now we've got to distribute the 4 to the 2 terms. So 4 times x squared is positive 4x squared. 4 times negative x is negative 4x. And 4 times negative 2 is negative 8. And let's see, do we have any like terms? Yes, we do. We have the squared terms, and then we also have the x terms. So let's add those together, and we're all done writing our equation in standard form. So f of x equals f of x, okay, hit the extended page, equals x cubed, negative x squared plus 4x squared would give us 3x squared. Negative 2x plus negative 4x is negative 8x and minus 8. And so here's our equation in standard form. All right? So that's all you have to, keep hitting the extended page. Now I can't find my things at all. Come on up. There we go. Little technological difficulty there. All right, so there's our equation in standard form. Okay, and so all the same steps, it's just one extra step, and then we had to multiply. We will look at this problem in class. And so the next thing we'll be looking at is graphing a polynomial function. I'm just going to introduce the steps, and then we'll pick up with this on Monday. So you're going to use your leading term to determine your end behavior, and we'll also write it out so that you get practice writing it in the correct notation. You're going to find all your real zeros, their x-intercepts, and you have your 4 different ways. You're factoring out a common monomial, you factor by grouping, using the rational root test, and then synthetic and long division or substitution. You're going to use the x-intercepts to divide the graph into intervals and choose a test point in each interval to graph. Your turning points will always be between your x-intercepts. Now, if you have a x-intercept that has multiplicity 2, then that one will be your turning point, okay? Because multiplicity 2 means we touch and turn. We'll find the y-intercept. That's super easy, just as easy as it was with the quadratic functions. And then any other information. Sometimes we have some symmetry, not in the same way as we will with the parabolas, but we might have some symmetry. We have our turning points, our multiplicity, do we touch and turn, and we use all of that to graph our function. Okay? So that's what we'll be looking at on Monday. We'll solve that last one together, we'll write the equation, and then we'll get right to the graphing. All right, so see you on Monday. Hope you enjoyed this podcast.